My name is Dave Watson with Power Standards Lab, and greetings from California. Hope your afternoon is going well out in Prague. Today I'm going to tell you about the Grid Thumper. It's a project that was originally funded by DARPA. That's the U.S. agency that does advanced research, and they invented the internet, self-driving cars, and now the Grid Thumper, as you can see in my background. After doing research on grid cybersecurity, we find the best opportunity for this product in testing the reliability of microgrids and gensets. So let me tell you a little bit more about it. It really is a system. It consists of the large enclosure that you see behind me that has a precision load bank in it. In addition, there's several other components that I'll show you more about. First, you should know that it is completely shippable anywhere in the world. As you can see, it's on a trailer that can be pulled by a truck. We can put it on a train or even a ship to send it wherever in the world that we want. Come on over, take a look. So as I mentioned, in addition to the large container back here, it's really a system that consists of a precision load bank, sensors to measure the impact from the signals that are created by the load bank. And for that, we use the PSL micro PMU. These are there's one inside the Grid Thumper, and then they're typically placed on the premises of the microgrid or distribution grid under test. And the third element of the Grid Thumper system is the database that collects the timestamp data from these devices. So let me show you around. After shipping Grid Thumper to a customer site, we typically plug in to their electrical system using these cables which are provided. It's designed to handle anything between 100 to 600 volts, single phase or three phase, and we designed this with safety systems all throughout, so it's a very safe system. Let me show you the load bank. This is the business end of the Grid Thumper. As you can see, it's a three-phase load bank where these are the resistors and cooling fins, large fans, one for each phase to keep it cool, and then these are the solid-state relays that are precisely controlled and time synchronized with GPS. The control latency on these is less than 1 microsecond. And again, there are safeties throughout this system to make sure that it works well when we expect it to. Let me show you the control room. The alarm that you hear is because I opened the door, and that there's a safety circuit on that. Since the door has now been closed, we can disable the alarm. So the first screen that I'm going to show you is a live feed from the database and visualization tool that I mentioned. This shows the three-phase power grid being measured around here with no thumping event underway. So next we're going to schedule an event. This is custom software that was written for the Grid Thumper, and we're going to schedule an event right now and let it run for you. We'll call it Prague Friday. The patterns are pre-programmed set of sequences, including the phase-to-phase that we're using here, and a 10% duty cycle we'll use in this test with a period of 1 second. It means the first tenth of a second the load will be engaged, and then the next 9/10 of a second it will be off, and that will occur 10 times for a duration of 10 seconds. we'll specify about 110 kilowatts of load this time, and for this test we'll do it at 7:38 our time. So this event is now queued up. We can queue multiple events as desired, and then we'll visualize on this dashboard. This event will launch in 2 minutes and 5 seconds. Here I'll show you that this is a schematic diagram of the wiring within the Grid Thumper. It shows the different resistors that will be pulled in sequence in order to provide the resistance that was defined by the power that I specified earlier. So we're in actually a countdown now, so as the countdown occurs, the proper relays will pull in advance of the actual thumping event. In addition to the configuration relays and resistors here, the relays that actually control the power flow are these thumper relays here. It can be either phase to phase or phase to neutral. So earlier I mentioned that this system is designed to help assure that power will be available to mission critical systems when you really need it. Well, how does it do that? Well, usually when hospitals and microgrids and data centers are designed, there's a lot of expensive equipment, including generators, UPSs, automatic transfer switches, and the like, all highly engineered to work in the factory, but they typically have never been tested thoroughly as a system under advanced test protocols that are emerging in this field. So the Grid Thumper is one of the few devices that can actually test that kind of equipment on site and assure that during an emergency the equipment will be available to assure that power stays on. Well, it looks like we're in the final stages of our countdown here. You can see that the configuration relays are armed and ready to go. They will close to give looks like 4/5 of the power will be provided in all 3 phases, and here it goes. So that's the test event launching off. The thumping relays are toggling on and off as programmed, and we sent 10 pulses into the grid by drawing power. This is the measured results from that test. You can see that the voltage actually drops here locally at this site due to the power flow that we just caused with this recent test. You can see each phase responds just a little bit differently. Proportionally, it looks like we're dropping about 6 volts at this site, 6 or 8 volts, and this is one of the indicators as to the inductance upstream from this device. And these signals can propagate throughout an entire microgrid, or in many cases even for miles across a distribution grid. What's of interest here in terms of analysis is what happens during the transitions. As you can see, there's some oscillations that occurred here at the end of each of these pulses. The characteristics of those oscillations will determine the stability of this segment of the grid, and with proper analysis can assure a facility owner that the system will be available during an emergency when they really need it. So this system is new. It's we're seeing a lot of interest from our customers. We're looking for more customers, and if you have someone who might be interested in this device, it is available now for lease or purchase. And the lease agreement is really comes with an engineer in the box, where we actually perform the test protocols and provide an actual detailed test report for a given site. So if you want to ask me about more technical details on the Grid Thumper, I can be reached at dave@powerstandards.com, and for pricing and availability, contact sales@PSL. Thanks so much for listening. Enjoy the rest